This video lesson is going to be looking at correlational studies. So we're going to be looking at what a correlational study is, how we can control different variables, when we use correlations in comparison to an actual experiment. But before we start, we're going to have a look at two different examples of correlations, and we're going to have a look at these at the start of next lesson. So try and have a little think about what you think are the problems with these studies. So the first one is that children watch more television that contains a lot of violence are generally going to be more violent children. So we could say that violent television causes violent behaviour. And the second correlation I want you to have a think about is it's raining outside, you see a lot of people with umbrellas, therefore we could try and state that whenever people put out umbrellas, it rains. So I want you to have a little think of these two, and we'll discuss them at the start of our next lesson. So we're going to start with learning what a correlation actually is. And a correlation is simply a relationship between two different variables. And in a correlational study, the participant will give two bits of information to the researcher. And the researcher can check, is there a relationship between these two things? There are no independent or dependent variables in a correlational study. All that we have are something called covariables. So if I was to look at a relationship between height and shoe size, they would be my two covariables, your height, your shoe size, and I'll be able to check, is there a relationship or correlation between those two things. So we only really use correlations when we want to see if there is a relationship between two of these covariables. So we could use the example I just gave down at the bottom here. Are height and shoe size related? Or we might want to see, is head size and academic scores related? So the larger your head, theoretically the larger your brain, the higher your test score should be. So we're trying to see if there's a relationship between different variables. We also use correlations when it's unethical to manipulate something in an experiment. So we might be looking at trying to make people argue and try and see whether that increases the rates of divorce, like this little picture down here. So the more we get someone to argue, the higher the chances of them getting a divorce. We can't do that in an actual experiment. It's unethical to make someone argue in order to get a divorce. But we can look at people who have got divorces and try and work out how much they've argued in the past. If we were looking at the effects of smoking here, we can't do a study where we get two people or two groups of people and go, you lot are going to smoke for 15 years, you lot aren't going to smoke, let's see which group gets the most cancer. Unethical, can't do it. But we can do a correlation. So we can ask people who have been smoking for 15 years. We can ask people who haven't smoked. And then we can check the rates of cancer in these two groups. You could do an alcohol study. Maybe looking at the effects of alcohol on the amount of driving accidents. We can't give someone some alcohol and put them out on the road to have an accident, see what happens, because it's unethical. But we can look at people who have had car accidents and check against whether they had alcohol at the time or not. So correlations are really, really useful when something is unethical that we can't test in a laboratory, but we can check the covariables and see if there is a relationship. So how would a psychologist actually carry out a correlation? Well, the first thing to do is operationalize the variables. You need to have a key understanding of what the two things you want to check are. That is the very first thing we do in all experiments. Then we get the participants' information on both of the covariables. And finally, we put that into a scatter graph. Scatter graphs are always used in correlations. And in your test, you might be asked to draw a scatter graph, you might be asked to interpret scatter graphs, and we'll go on a little bit later to look at how you'll actually do that. But remember, scatter graphs are always used for correlation studies. So when we're interpreting graphs for correlations, there's different types of graphs you might get. You can see here, you've got this first one. We've got a very positive correlation. So as one of the covariables is increasing, so is the other one. So that's called a positive correlation. It's a high positive correlation because there's a very straight line of fit. You'll never have to put a line of fit unless you're asked specifically to do it in your exam. But you can see all the lines are pretty close together. This second one here is also an example of a positive correlation. You can see roughly as one variable is increasing here, the other one is also increasing. They're all going in this general direction. But they're a little bit more spread out, so it's a low positive correlation. The tighter those little dots are and the covariables are together, the stronger the strength of the correlation. We've also got a no correlation, which is when there is no relationship between the two variables. They're all spread out all over the graph. There's no clear relationship from looking at it on the scatter graph. And the bottom two here are the reverse of the top two. So this is where we've got our negative correlation. As one variable increases, the other variable decreases. So negative correlations, and we'll have a little look more about what they're going to be in a bit, will be going in the opposite direction. The line is in the opposite way to what we saw in a positive correlation. And the exact same rule applies. If they're spread out, it's a low negative correlation, and if those lines are nice and tightly together, it's a high negative correlation. So you just need to be able to pick out from these graphs which types are which type of correlation. And all correlations have something called a correlation coefficient. And this is a number that will be assigned to the strength of the correlation itself. And it ranges from -1, which would be a negative, really strong negative correlation, to +1, which would be a really positive correlation. And any correlation can be positive or negative, or it can be 0. And the larger the number, the stronger the correlation. So the strongest positive correlation we can get would be 1. That would mean as one thing increases, the other one increases as well. And the strongest negative correlation we can get is -1. So as one thing increases, the other thing also decreases. So if we have a look at a positive correlation, that would be sort of your perfect positive correlation here, where all of the dots are along the same line. So this is as one variable increases, the other also increases. And positive correlations only go from 0 to +1. And they can fall anywhere in there. The higher they are towards +1, the greater the strength of that correlation. So easier example would be the taller someone is, the heavier they are to be as well. So you can see as their height increases, so will someone's weight as well. So you've got two things that both increasing at the same time. That would be an example of positive correlation. A negative correlation, on the other hand, goes in the reverse direction. So as one variable is increasing, the other one is decreasing. And this now goes from 0 to -1. And the closer the score is to -1, the stronger that negative correlation is. An example might be the more alcohol you drink, the less you are able to remember. So the more and more units someone has, the less and less and less and less and less they're able to remember. One is increasing while the other variable is decreasing. And the final one you've really got to know about is this no correlation. You can see on the graph, you wouldn't be able to put a line of best fit on there. All of the dots are spread out across the scatter graph. So there is no relationship between the two covariables. And you're going to get a correlation coefficient of 0 or very close to 0 for a no relation or no correlation. An example might be shoe size and IQ. There's not going to be any relationship between those two things. They're not related in any way. There's no way having a really large shoe size is going to increase your intelligence in any way. So certain things will not be related at all, and they are no correlations. So the main difference between a correlation and an experiment really is that in experiments we manipulate an independent variable. In correlations we don't. All we do in correlations is measure two covariables for a participant and check if there is a relationship between them. So that's the difference between what an experiment is, where we manipulate an independent variable, and a correlation, where we simply measure covariables. And what we're going to be able to look in our next lesson is the strength and limitation. So remember to go back to that first slide about the umbrellas and rain, and about TV and aggression in children, and have a think about what the potential issues are with using correlations.